Problem 15. Last Zillow went online to shop for black pepper and found 30 different black pepper options varying in weight and price, shown in the scatter plot below. In ounces, what is the weight of the pepper that offers the lowest price per ounce? So this question is not really asking you to, do some arithmetic or something. It's really asking you to understand how fractions work. So price per ounce, right? That is the fraction. How do we minimize fractions? Well, there are two ways. The first way is to lower the numerator. Right? Smaller the numerator, the smaller the number. Or we can increase the denominator. The ideal scenario is where we increase numerator and we decrease numerator and increase denominator at the same time. Right? This is the most optimal way, but if we have to settle for one of these two, that will work as well. So let's first understand this, right? We want to have as large of a denominator as possible. So we want to have, as large of a weight, but for as small of a price. So ideally, it's somewhere over here. But let's look at it. There's nothing over here, right? The black box I circled. What about here? Well, there's nothing. There's nothing here. There's nothing here. So there must be another way to go about this. Well, you're given a grid, and grids are typically known for lines. So let's first draw the line right here. That line is where price is equal to weight, right? So in other words, what is the price range of dots to the above this line? Well, plots that are above this line is where the price, right, is larger than the weight, right? And if we look back to our fraction, that means we increase our price and decrease our weight. Well, that's obviously very bad, right? Because that means we're increasing the fraction. Since decrease the numerator and increase the denominator decreases the fraction, the vice versa must increase it. So any point that's to the above this line should not be considered, so we'll just cross it out as such. And on the test, you just do with a pencil to avoid these points from distracting you. So all the points we have left to consider, I'll circle it in red, are this point, and this point. Well, which one would work? Well, what are lines beneath this y is equal to x line? Well, these lines, right, must have a price, right, that is less than the weight. And this is exactly what we want, because that means we're increasing the denominator and decreasing the numerator. But the more extreme, right, the more this line gets close to the x-axis, the larger the weight would be, and the smaller the price would be. So in other words, we want to find the line that is closest to the x-axis in terms of slope. And do you understand from slope, right? You want the slope to be as small as possible. So the k to be as small as possible. Well, if we just roughly draw it out, that's this line, right? And then that is, here, that's getting very, very messy. I'll do it in a blue color. That is roughly this line, and that is roughly that line. So notice here how I have to go up a little bit, right? Do you see that gap here? I'll zoom in. So if I zoom in, do you see how like there's this small gap? I'll do it in purple. Sorry for the confusion. Like, did you see that little gap? Well, just from that visual like inspection, we can see that obviously the line that passes through this point right here would have a smaller slope since it's closer to the x-axis. So your answer choice would be C. But worst comes to worst, right? We obviously don't want to minimize it. So worst comes to worst, we can eliminate 1 and 2 from our initial analysis and just choose 3 should it be a guess.